Hello everyone, my name is Federico Zanetello and I'm the creator of fivestars.blog. On my website, I take deep dives into inner workings and behind the scenes of what is Swift in iOS development today. However, in this talk, I'd like to take a different approach, and instead, I'm happy to share with you some of the lessons that I learned during the past 3 years of building and shipping SwiftUI apps, coming from a UIKit and APPKIT developer perspective. So let's get started. Lesson number 1. SwiftUI is not UIKit nor APPKIT 2. We start with a big lesson right away. In SwiftUI, things are just done in a complete different way. Most importantly, we have moved from multiple imperative SDKs to a single declarative one. Now, it doesn't matter if we are just getting started with building apps for Apple platforms or if we have over a decade of experience. When we talk about SwiftUI, we are all starting from scratch. Of course, knowledge of previous UI frameworks give us very good insights on how things work behind the scenes, but it's not really helpful when we start learning SwiftUI. Actually, it might even become a disadvantage, as we have a big baggage of expectations that are simply no longer true in SwiftUI. An example of expectation that is no longer true is about view ownership. Because, and this is the next lesson, in SwiftUI, views are recipes. So this is of course because of the SwiftUI nature of being declarative, and which really means that we no longer own views. Instead, our code or view code looks more like recipes, where we, as developers, specify the ingredients, such as the view behavior and look, but it's then SwiftUI that does the cooking for us. So managing things like transitions and more, all of that is taken care of for us. And so most things that we are used to do in UIKit and APPKIT become implementation details that we no longer need to take care of, which is awesome. However, yes, this actually means that we are giving up control of our views. So let's make an example of this. Imagine that we want to take this screen and we want to change the background color that we show on the screen by tapping this button. So with previous UI frameworks, what we would have probably done is take the screen, the view on the back, and set its background color property. Now, SwiftUI is state-driven, so we no longer need to make these kind of changes directly ourselves. Instead, what we can do in SwiftUI is define a new property, and we associate that property with a special property wrapper called state, shown right here on the slide. And next, what we do is we make our view observe this new state, and we do that right here on the view body of our new view. Next, what we do is we take our button, and in the action of this button, we just change this property. So in this case, we have this background color property, and every time we tap this button, we randomly change color between red, white, and black. However, we are not telling SwiftUI what to do when we change this color. We just tell, okay, you change this state, and whichever view is observing to this is going to react to that change. One thing that is very important to notice is that background color is something that we have defined, is a state that we define. There is no standard background color in SwiftUI. So we could have renamed this with any other name, and the state was going to be observed anyway, as long as that was also the state observed in our view body. Now, looking at this example, something that might be curious is, especially coming from earlier frameworks, is that only this view and nobody else can change directly this background color state. So let's imagine that this view has a parent view. That parent view, at least as per current definition, will not be able to change this background color. So you might be wondering, how can other views or even models change the state belonging to other views? And to answer this question, we need to have a look at how SwiftUI communicates. So we need to have a look at the communication patterns in SwiftUI. And probably the most common way to do this in SwiftUI is via bindings, and we see an example right here. So like before, we have this very simple screen where we have a view, we show a small description and a toggle. And we want this toggle to have a state that is shared between our own view and the toggle view. And like before, how to do this is via defining our own state. In this case, we have this isOn_state. And then we share it with our toggle. But as you can see, we are not just sharing the value of our state, but we are sharing this $sign, which basically share a projection of our state to this other view. And then this other view will be able to both read and set this state. And when that view will set that state change will also be reflected in our original view. It's very important to understand that we still have only one state, and that this view, this FS view, is the original and only owner of that state. But now we can basically borrow that state to as many views as we want, and those views will be able to both read and set that state. And that change will be reflected everywhere else where this state is observed. So yeah, all of the concepts that we've seen so far are quite alien coming from previous UI frameworks, right? So this is actually the next lesson. Lesson number 3 is that it is expected to struggle when learning SwiftUI. So even things like presenting a sheet or popping to the root of a navigation stack become hard when we move to SwiftUI. And this is just because we've been working with different tools in a different mindset all of this time. Don't worry, you're not alone. We are still all of us figuring things out, including the SwiftUI team at Apple. Speaking of, a word of caution. Don't believe everything you read online, especially when we talk about SwiftUI, because you can find very often people that say, okay, this thing is impossible in SwiftUI. What they really mean is that they just haven't figured out how to do it in SwiftUI yet. So yes, things will be hard at first. Things won't make sense at the beginning, and this might take a while. It might take days, weeks, months even, until at some point we just start thinking the SwiftUI way. Then things will just click, and then there is no going back. Everything will be very, very easy. So with this happy note, let's move to the next lesson, which is in SwiftUI, everything is a view, but not every view is a view, at least not necessarily. So in SwiftUI, we don't have concepts like view controllers, delegates, and similar. They just do not exist, at least not yet. So with that being said, it shouldn't be surprising that things like key events, so for our app, are delivered directly to views. And by key events, I mean things like when a view appears or disappears, or when we want to have some state changes notifications, drag and drop events, and many, many others. So this might sound a little bit upsetting at first, because we already know what happens when we put all our presentation and business logic in a single view controller. We all know what MVC really means, right? So yes, it seems like SwiftUI is pushing us to put everything inside views. However, just because things have to be delivered to views, it doesn't mean that we cannot properly separate and define different entities with clear and distinct responsibilities. So let's take an example of this. In SwiftUI, we can build views which are containers. So containers are just views that do not explicitly define any UI themselves. And here in this slide, we see an example of this. And this container view, again, it's just a simple view, so it's a new definition that conforms to the view protocol and has its own view body, like every other view. And it also comes with its own state. In this case, we have this model where we will store all our business logic. Then, if you look at the body, we see that there is actually not explicit a UI here. Everything is, all the UI is actually delegated to another view. In this case, it is actual UI view. And so, yes, this is where our UI is actually defined, not in our container. And this is very important. The actual UI, we see that is driven by our model. So in this case, it's a model that tells this view what to represent. In this case, we have this model.elements. And all the important events are forwarded from the view to our model. So in this case, we see that anytime the user interacts with any of the elements in our container, this event will be forwarded to our model. And also the onAppear event is forwarded to our model, which means that is our container at the end that has all the business logic and knows what is the state of our current flow, and will be able to decide what to do next. So containers are just an example, but I think especially from people coming from the UIKit world, we are probably familiar with concepts and patterns like the coordinator. And guess what? In SwiftUI, even the coordinator is just another view. So in case, just to make sure that everybody knows what we are talking about, the coordinator pattern is a pattern or an architecture in iOS where we take the app flow logic and we extract it away from view controllers. And we bring this to a new entity called coordinator that defines no UI by themselves, but knows and controls the overall app state and flow. So as I mentioned before, coordinators in SwiftUI are just views. So in this example, we see this flow coordinator definition that, like before, like for containers, conform to the view protocol and has a body definition. And in this case, we have a simple and generic two-step flows. So this coordinator will have just a couple of screens to show, and then it's over. The coordinator, in this case, is very simple. So we define the model right here in this definition. And thanks to this roots property, it will know at every single time, at any time, what is the current step, where we are currently in our flow. And like other coordinators in UIKit as well, we have also a completion block. And this completion block will be called when this flow ends. Now let's have a look at what it does, what it defines here in the body of our coordinator. And we see that, yes, like before, we are delegating the actual UI implementation to other views. In this case, we have this first screen view and this second screen view. And very important, both of them accept a closure as a parameter. Those closures will be called when that step is finished. And then it's up to the coordinator to decide what to do after this closure is called. So in the case of the first screen, what we do is just we push to the second screen. And in the second screen example, what we do is just we call the completion block that was given to our coordinator to tell the coordinator in the higher hierarchy that this flow is finished. In conclusion, despite seemingly having only views at our disposal, it's still very possible to separate entities and exposabilities even in SwiftUI. Okay, let's move to the next lesson. And this is probably surprising, coming especially from me, but yes, the next lesson is that SwiftUI is slow. And as you can see, I'm also putting a huge asterisk over there. So there is a disclaimer that we will see in the next slide. So SwiftUI comes with all sorts of optimizations. However, those optimizations become implementation details that are not managed by us. They're all done by the SwiftUI team for us. This actually means that our app might just get faster by building it with a newer version of Xcode, because newer version of Xcode should have a newer, improved version of SwiftUI, and that should come also with optimizations. However, there is a limit to how much we can get for free just from this SwiftUI team. And this is the disclaimer that I was talking about before. SwiftUI really is as performant as our code makes it so. So a common pitfall is to have a lot of parameters, a lot of states, and a lot of dependencies in every single view definition that we have. And the thing is, the more things a view owns, the less performance we might get. So instead of doing this, I would like to share with you some tips. So the first tip is to isolate state as much as possible. So thanks to this, what it means is that every view will only observe the state that they are really interested in, and so we don't need to, especially not we, but SwiftUI, SwiftUI doesn't need to recompute over and over these kind of states, this kind of bodies of all over views, just because a state has changed. And speaking of, we should only publish things that are relevant for the UI. We know that yes, in SwiftUI we have all these kind of cool property wrappers, but we should really think if we need to have to use those property wrappers, because sometimes we have properties that belong to the view model or the model, but they should not really be something that all views need to be aware of. So really think if you have to publish every single one of those properties. And of course, try to make every view observe as little as possible, so that that view only reacts to the changes that they really care. And here, of course, I'm sharing a lot of links, so if you want to dig deeper in any of those topics, please have a look at those. All right, so yes, in conclusion, SwiftUI is clever, but it still needs our help. Now, moving to the next lesson. SwiftUI is still very new. New patterns have been introduced at every major release, and all patterns have been deprecated. Things have and will change for a few more years. Similar to Swift evolution, the SwiftUI team listened a lot to the community feedback. And how we can give this feedback is via the feedback assistant, which is, in case you're not familiar with feedback assistant, this is the way that we can submit tickets to Apple. And those tickets can be bugs, can be feature requests, etc., etc. In this slide, I'm sharing with you the link of the web version of Feedback Assistant, but they also have a native app both for iOS, iPadOS, and macOS as well. So if you haven't yet, please have a look at this app and start submitting feedback as much as possible. I know that for a lot of people, the experience is not as good as mine, and in my case, I've received a lot of responses, especially when I submit feedbacks around SwiftUI, and I never close as many feedbacks as when I submit them on SwiftUI. So yes, especially the SwiftUI team, I believe they really read every single of our feedback that we submit. But I know, yeah, this is not the experience that everybody has, so I'm happy to share with you now a few pro tips to make your feedbacks better and with more chance that they are going to be closed or at least get a response from Apple. So those tips are: be as narrow and as concise as possible. So let's say that in a screen you have 3 issues with SwiftUI. If you believe those 3 issues are something that is not up to you but it really is on the framework, you should file 3 separate feedbacks, one for each issue that you're having. Next is to file feedbacks as early as possible. So Xcode betas are released for us to make sure our app doesn't break in the newer version of the SDK, and also to try out the new APIs that Apple might have introduced. But it's not just to try things and see how they go, but it also, this is the way that we can try before they become out with the official release, and so we can report back any kind of unexpected behavior or things that might be broken to Apple before we have this official release. So yes, file as early as possible, and particularly you need to follow up when new SDKs come out. So the next version of Xcode beta that come out, or the next version official release of Xcode that come out, please follow up on your feedbacks. So otherwise, if you only submit a feedback once and you never touch it for years, this might be forgotten even by Apple themselves. So if instead you follow up every time, this is kind of a reminder for the team as well. Oh yes, we still have this issue open and we should fix it. For bugs particularly, please add reproduction code. So especially when we talk about SwiftUI, it's very easy to make a very quick prototype, a very quick demo that make to show your issue. And if you want to be extra nice, you can also record yourself showing how exactly how to reproduce this issue, and that will help a lot, especially the screener, so they are able to forward your feedback to the right person in the team. As I mentioned before, feedbacks are not just for bug reports, but they can also be used as feature requests. So let's say that you have an idea of a new view that you would like the SwiftUI team to create for us, or maybe a modifier, a style, etc., etc. Well, in that case, you shouldn't just write in the feedback, okay, please make this, or please give us this, or something like this. Instead, we should also tell why we want that new feature, new API, etc., etc. Describe your case, because that would make a much stronger case for the team to say, oh yes, we really need to implement this. Okay, so yes, I wish you very good luck with Feedback Assistant. Again, if you follow those tips, I'm pretty sure that your feedbacks will be very much listened and you will see very good results from Apple. Let's move to the last lesson of this talk, which is UIKit and APPKIT are here to stay. So I hope this is kind of a reassurance for at least some of you. And let's see what I mean by this. First, SwiftUI itself heavily relies on both UIKit and APPKIT behind the scenes. So yes, they are going to stay here for a very long time. Also, you should not consider SwiftUI as a replacement of UIKit and APPKIT. Instead, you should just think it as a new tool that you can use whenever you want. As developers, we love to have as many tools as possible at our disposal, so we can choose the best one for every single situation. And SwiftUI is just one of those. It's not all or nothing. More specifically, actually, in the Apple, the SwiftUI team at Apple made sure that we can mix and match UIKit and APPKIT with SwiftUI. And they provide us a lot of objects that you see here on screen to make sure that we can embed SwiftUI views in UIKit and APPKIT and UIKit views and view controllers in SwiftUI. So please go ahead and try to do this as well. So even if you have already a large code base, that doesn't mean that you cannot use SwiftUI, but you can start maybe in just a small corner of your project to start implementing SwiftUI just there. Last but not least, don't forget to experiment. So I promise it's going to be fun. With this, I'd like to thank the conference organizers for this opportunity, and I thank you all for joining me in this session. If you have any questions, you can find me on Twitter. My handle is right here on the slide. And I wish you a great rest of the conference. Thank you very much. Bye.